Okay, we are going to work on homework 3. Let me see, where is it? So, question number 1. All right. I hope you can see well. If not, let me see if I can make it bigger. Okay. All right. So I think that's better, right? Okay, that's good. So question number 1 for homework 3. So first thing, what we're gonna do, we are going to read the condition. It says, given the probability distribution shown to the right here, we have probability distribution for A and distribution for B. All right. Complete the following parts. A, compute the expected value for each distribution. So let's move to Excel. There we go. So we need to compute the expected value for each distribution. Expected value, nothing else but the average. Whatever the average is, that's gonna be our expected value. So what is the formula for expected value? I'll write down somewhere here with red color, and let me see, bold, and I'll choose, let's say, a little bit bigger. Okay. E of x, it's a probability, expected value, E of x, or it's also equal mu. We put mu like this, writing like mu. Okay. And that is equal, the formula. Oh, I thought I'm going to use red color. I don't need this. You know what? It's better. I'll show you here. 1 second. It's difficult to write down in Excel. So if I click example here, write down please real quick, and I'll explain. This is mu, which is average. Here is expected value, E of x. What do we have here? Every single x that we have here, x, we need to multiply by probability of x. So 0 times this one, 1 times this one for both distributions, okay? And what means I? That means it's every time the first one, second time, third one, fourth one, fifth one. And I, it's going to run from 1 and it's going to be 5 because we have total 5. So write down this formula and we're going to use this formula. All right. And moving to our Excel, so to work with, since this one is wait a minute, why both of them are distribution? Hold on, why both of them are distribution? Let me shut down and open again. Seems to me it's transferred to Excel wrong. Okay, distribution A, it's x, distribution A is probability, and then distribution B is x, and distribution probability. So I need to do expected value, which is going to be the average. So I'm going to insert the row here. 2 rows I expected because I highlighted these 2 columns. So it inserted 2. I will need 2 of them. So expected value Based on our formula, what we need to do, first we need to take x and multiply by its own probability. To remind you again, see, every single x we multiply by its own probability. Let's do it. So equal sign x multiplying by probability, and here of course I will get x because it's 0, but from here I'm going to drag down, and I'm not freezing anything because every case has its own probability, and here we got it. So the same thing I can do here. So this is gonna be my probability of x, and I will do equal this times this probability, okay, and drag it down. We got it. Next, see, I have to get multiplication. I got it. Now I need to summarize the symbol meaning sum. So I need to summarize, moving on. So I need sum of this the expected value. So I'm going to formula. Here is auto sum. I'm clicking. Oh, you don't see it. 1 second. Okay, here it is. So I'm clicking sum, and I fixed the cell where I want to go. It's under probability. I mean expected value for each probability. Now I need to add them. Auto sum. Okay. There we go. Enter. And the same thing I'm doing here, or I can drag this one. There we go. These two of them I am going to clean because I don't need it. I need this sum of these two. Yes? Okay. So next, so we have 0.89, and here we have 3.11. Let's put 0.89. Did I copy the right one? 05002, okay, 002, okay. 0.89, here is mu. It's asking expected value for distribution A, 0.89. Expected value, that's the average we told you. But I should have opened it. Okay, from next question I'll open it. Now I can't open answers because it will change all numbers. And this one is, how much we got here? 3.11. All right. What is next? Find the standard deviation. Let me, standard deviation for the distribution. You understand what is standard deviation, right? How far is every element is drifted from the average. So for standard deviation, write down this formula. It's going to be square root of variance squared. Okay, square sigma equals square root of variance squared. And then writing down this formula. What does that mean? It's going to be square root. I'm taking every single x minus expected value. The expected value here we got mu is this and this, for example, this case. In our case, it's going to be 0.89. So every single x, I need to subtract 0.89. Okay, and once I subtract, I'm going to square every single difference, square, and then multiply by probability. Once I am done for every single one of them, I will add them up, summarize, and take square root. Okay, so write down this formula and we get for it. So, first thing, what am I going to do? Standard deviation, I put it here, STD. All right. Let me make it more narrow because we don't need this wide. There we go. This is distribution A. I mean X for distribution A. This is probability of distribution. Just in case if we need to add cell, we can do it. So number one, follow your formula. I'm going to do X minus, okay, I need to move this. You know what, let me bring this down 1 second. So I will have enough space here. There we go. Okay, and this 3.11 I can move down right here. Okay, all right, so we have standard deviation. First thing we have to do, instead of, I don't want to do it right away, standard deviation, we are going step by step. It's going to be first X where is my X? Here. X minus expected value. There we go. And probability of X. Okay. So let's do that. Every single X, which is in this case, it's gonna be 0 minus expected value, which is gonna be here, 0.89, right? And 0.89, I'm going to freeze it because from every single X, I'm going to subtract the same 0.89. So once I drag down letter C, the column C is gonna stay. Only arrow is gonna change. So I'm freezing 9 only. There is no need to freeze the column. So here we go. I freezed it, and now I'm dragging down. All right. See here, first number is negative. That's mean deviation. This one is below average. Okay, this is a little bit above, further above, and more above, and this is maximum above. Okay, next step, we subtract it. If you look at your formula under square root, we have X minus E of X, expected value, and we square it. Okay, that's gonna be power 2. So I'm going to write down here X minus E of X E of X, and 2 squared meaning power 2. Okay, we're gonna square every single one of them. So let's write down. It's gonna be equal, going to our formula here, more functions, typing power. Here we have power, double click, power, and I'm going to square this one, right? And the power is going to be degree 2. If I would need to put cube, I would put 3. So here is power, and here you see result. Once I click, I got it. Now, once I drag it down everywhere, it's going to be power 2. Let's see. See, because I put the number 2, I didn't click the cell, just number itself, so it nailed it. So everywhere it's going to be square. So we squared it. Next we have to do, let's look at the formula here. Let me open it. So this is here we squared it. Now we need to, all this result, we need to multiply by its probability. So the square we got, we need to multiply by its probability. And then add them up, and after that take square root, okay? So next we have to multiply by probability. So let me copy this. Copy, paste, okay, and it's going to be multiplying by probability of x oops, where is my letter x? Oh, here. Probability of x. So which means I'm taking this number, right? Subtraction. We put equal sign, clicking on this, and then we're multiplying by probability, which is this one. Okay, dragging down, and I got it for every single one data. So next we need to summarize, which is here, sum. And after I sum, I'm going to take square root. So once I sum it, okay, and practically STD, standard deviation of distribution, okay, is gonna be square root. Here it's gonna be, the formula is SQRT, square root. Hold on, let me do it easier way. So click more, so square root. Here, what is this one? It's return the square root of complex number. No, we don't have complex number, we have this one. And what is this? Return the square root of number times p. No, we have a square root, just the square root of the number. That's all we need. Okay, since it's I'm already clicked on the cell where I want the data goes, clicking OK, and I'm going to choose which number I want to put there. Square root of which number? This number, right? Okay, and clicking enter, and I got 1.085. Let's put the answer. How many decimals? 3 decimals. 1.085. Let me see if there is anything to round. 853. So nothing to round more. 1.085. All right. So let's check. Yes, fantastic. So next thing, you're gonna do it by yourself the same way. You're gonna do same way. For the second one, okay, standard deviation for distribution P. You can do it exactly same way. For standard deviation, you can look at the formula and then do calculation. STD, here this one is standard deviation. So this is your answer, standard deviation. Let me highlight on it. There we go. So you have to do same thing, which means the same way, x minus e of x, and then you have to square it, and then you multiply squared value by probability and get square root for this case, and you will be able to get the answer. Okay? Next one, moving to next one. Do you want me to do it? You know what, I guess I can make it easily. So let's see what I'm going. Look how easy I'm going to do it. I'm going to show you. I'm copying this whole thing. And let me clean this. So this is gonna be paste. Where is my paste here? Oh, doesn't paste. Let me try one more time. I need from e of x because I deleted there e of x. Okay, it's my mistake. Copy, and then from here I'm doing which one? Okay, let me see if it clicked on formula. Yes, it did. So therefore, first one, it's gonna be x, oh here it is, x, and this one 0.09. okay, it's adjusted, looks like. Okay, as I copied the entire formula, adjusted, therefore this one also I can copy. All right, we can do it ourselves, that's all right. So we're gonna add it. Where is it, formula? Hold on. We are clicking formula, addition. Okay, let me add it here. Got it. And then use this formula. I'm going to copy here. I'm pretty sure it's gonna work. 2.47, double click. See, came here. But to do that, see, it's one corner, one cell here I left out and put in second. All right, so if you won't leave here one cell, then it will take from here. So you have to leave exactly as amount of cell as here as you had here. Otherwise you have to do it yourself again. See, SQRT of F25. Okay, we got it. So that was easy. I'm going to put sigma, standard deviation. Where is my standard deviation? 3.11. No, that's not the standard deviation. 2.471. 2.471. Did I put the right one? Yes. Check the answer. What did go wrong? Hold on. 108. It's correct. 2471. It says incorrect. Round to 3 decimals. Let me double check formula. Here it's equal this. Okay. Here also it is okay. This e of x expected value is correct. Now checking this one. Oh, I see. Because here we have it frozen. That's why it kept it. So what we are going to do, hold on. Here we have this C22. So in this formula, I'm going to put 22 instead of 9, 22. Then it will take No, that's not 22. C, 25. Okay. Highlight a different one. 25. Okay. We have it. See? Double click. All right. Now we are fine. So once I drag it down, we got it. Everything else also will adjust. And how magically we got the same 1.08. Let me check this one. Square it. Squaring this. Okay, this is correct. And here I'm multiplying by probability. This is correct. And well, we get again the same. Let me see. Okay, let's try 1.085. .085. Well done. So both of them have same at a standard deviation. Okay, and now we need to find what's the probability for distribution A when X is at least 3. At least 3 meaning 3 and 4, right? For distribution A. So 3 and 4, probability here is for 3, 0.09, here 0.02. It will be 0.11, right? Because we need to add. So I can put this formula here. Probability for X, it says greater equal. I can't put greater equal. I'm putting like this. Okay, excuse me, because there is no such mathematical symbol. But at least you know what does that mean. Equal 3. It's going to be equal probability of 3 and then plus. Let me cover this. And then plus probability of 4. Okay, this small letter P also. P. Okay. That's it. So probability for A, here we have 0.09 and 0.02 will be 1.1. And we need to put in how many decimals? Type in integer or decimal, do not round. Okay, 1.11. No, 0.11. Excellent. And greater equal 3 for B. For B, we have what? 0.24 and 0.5. 0.74, right? Okay, we are done. Moving to question number 2. Here it is. Use this result to compare distribution A and B. Distribution A is right skewed. Distribution B is symmetric. Okay. Let's find out. Distribution A symmetric, B is left skewed, and distribution A is right, and so on. All right, let's figure it out. All right, I just by accident pushed the answer, but that doesn't matter. I will explain. Okay, so let's see. We have, let me move it here. Let me see. Okay, that's good enough. So what do we have numbers for A? Let's look at A. We have 0.5, 0.24, 0.15, 0.09, 0.02, and our average, which is E of x, expected value 0.89. So those are around our average, correct, or less, correct? So it's if it's to the left, if data are going to the left, just like we have here, then we are dealing with right skewed data. But for the case of B, look at that average. In average, numbers are expected value 311, and here we have small one. So if the average is to the right of these numbers, right, that means the distribution is left skewed. Okay, now let's one more time. 0.89. 0.89 is higher than these values, correct? So it goes the higher 0.89 is higher than 0.89, but they are around 0.89, 0.5, 0.24. They are not too far away, but that's why it's towards left, including average. Average is also towards left, less than 1. So it's going to the left. That's why distribution A is the right skewed. But for distribution B, you have 311. Look at these probabilities and distribution. Average is very high. Okay, that means average is on the right side of these numbers, correct? So at this point, it's far away from this number, so it goes to the right because it's on the right side, and B is gonna be as a left skewed. Okay, okie dokie. Moving to question number 2. Let me see what we have. Question number 2. Let me open the answer so it would be easier and faster to cover it. I already did once math, you already know. So we need to compute the mean. Computing the mean, that's mean computing E of x, which is what we are doing, taking x, multiplying with probability of x. Look, taking x, multiplying by probability of x. To make it easy for you, all you can do, click escape, all you can do, move these numbers 0 through 1, 3, 4, 5, 6. Since you have 6 of them, you can insert here. Okay, we can insert 2 lines because we need 2. There we go. Highlight and 2, click insert. I will increase 2 of them. So it's gonna be 0, 1, 2. If I highlight and then drag down, it should automatically fill up till 6. Okay, there we go. And here where probability is, you put this data. All right, and then to find out average, meaning E of x, so all it automatically will pick it up for you. So you enter probability and these numbers, and you will get your average. A standard deviation the same way. It's gonna be, here it is, standard deviation. And if you don't get the answer, just double click, see, make sure you get you picked up the right formula. If not, just copy the formula again. All right. And if you have question, obviously I am one phone call, one text message away. And here we have probability of x greater equal to, starting from 2, including 2. What you're gonna do, add them up, 0.19, 0.09, 0.05, 0.04, 0.02, and it should give you 0.39. All right, adding them up. Okay, moving to question number, let me move it down so you can see. Moving to question number 3. Well, it's gonna be exactly same way. You already know what to do. Okay. Sigma, you have to do, let me look here. I think it's, yeah, I'm gonna do same way. Let me check this. Yeah, exactly 1-to-1, same formulas you're gonna use. Okay, number 3 also the same. So moving to number 4. So what do we have? Let me bring it closer so you can see better. All right. Okay, that's good. So first of all, what we're gonna do, we need to understand that we are dealing here with binomial distribution, because it says determine the mean and standard deviation of the variable x in each of the following binomial distribution. Let me explain to you real quick what binomial distribution mean. Binomial distribution is when we have total amount of cases, which means in here case A is 3, in B is 4, 3, 4, okay? And that's a firm at the first condition. Specific, you can't have more than this much. It has to be specific amount of total cases. Then it has to be also, in this case it's a P, they put as a P, probability of success. 0.6 is 60%, 40%, 50%, 20%. And accordingly, you can calculate probability of failure. And the cases are independent. They don't depend on each other. Let's say if you grab some yellow color the candy from the jar, it doesn't mean that second one also it's gonna be, it depends on, it's gonna be yellow. Okay, so that's another condition. Okay, how we gonna calculate here mean and standard deviation? I'm going to open the formula, since these letters it would be inconvenient for me to write. So, but that's all right. Here is mu is equal n times p, total amount of cases times the probability. That will be our average. Okay, n times x. Write down that formula, and that's what we need to find out first. Let's do it. So for n is equal 3 and p is equal 0.6, what we are going to do to find the mu, we are going to take n, right, which is 3, and multiply by 0.6, which is going to be 1.8, correct? See, I forgot. I wanted to open all answers so it would be easy. We just do the math and see the result. Right now I cannot change because I already started. Okay, from number 5 I do that. Now, standard deviation. Let me open the standard deviation. Here is standard deviation formula. Sigma equal square root of n times pi, 1 minus pi. What means? Well, n times pi is our average, mu, right? It's the same thing, n times pi. This is our mu. 1 minus pi, it's probability of failure. If pi is a probability of success, let's say 60%, then probability of failure is going to be 40%, right? So 1 minus 0.6, so 40%. Then you take square root. So we will do it in Excel, okay? N pi and 1 minus pi. We will work in Excel for this case. If you want, you can put n times pi also in Excel, doesn't matter. I guess could be easier. Let's do it. So I'm opening my this, let me open new page. All right, so here I'm writing my n. Here I'm writing my pi. I'm going to put p pi. I'm not going to waste time. I can find here insert symbol 5 pi, but we already know. In this case, we had what? Free n 0.6, n is free, pi is 0.6. Let me format it to go everything in middle. Home, here I will choose this. There we go, so to have it in the middle. So here I'm going to put this symbol mu, okay, which I can't type it, so I'll just put mu. I put mu m, I think this is my u. Oh, I put an m. Hold on. Let me zoom it here. Okay. So mu all right, and mu is going to be equal n times pi, right? Okay, now we need to calculate our sigma, right? Remember sigma, square root, here, square root n times pi times 1 minus pi, or n times pi, which is total cases, times pi probability of success times probability of failure, and square root. Okay, so let's do it. Standard deviation, STD. Okay, I want to this one also format, say in the middle. So we have square root. It's gonna be SQRT square root in parentheses. What do we have? N. I think actually n times pi, we already have it. It's a mu, right? Hold on. Oh, I didn't put equal sign. Equal sign times this mu times, and in parentheses 1 minus pi, right? Closing parentheses, and one more parenthesis for SQRT, and enter, and we get 0.848. Let's see how many decimals we have to have. 3 decimals, so it's going to be 0.8485, 849, huh? 0.849. Good job. Moving to next one, n is 4, pi is 0.40. So I can replace it, n is 4, and here is 0.40, 0.4, and collect 1.6, 1.6, and standard deviation is 0.9. Okay, see it rounding up 3 digits, so the further coming 7, so it's gonna be 9 become 10, 7 become 8, so 0.980. 0.980. Fantastic. And then coming same thing, 3 and 0.5, 3, 0.5, and collecting 1.5 is our mu, and our standard deviation is 0.866. And the fourth one, you can do it, right? I'm not going to continue the fourth one. All right. So moving to question number 5. Yes, I'm leaving. Don't worry. Okay. A recent survey reported that 30% of 18 to 29-year-old in a certain country, survey report 39% of this age in a certain country own tablets. Okay, so our pi, it's gonna be 39%. It's a probability of success. So pi, I'm writing 0.39. All right. Next, using the binomial distribution, compute parts through A through E below. All right. So what's the probability? What's the probability that in the next 6? So the important n number total cases. It's not 18 through 29 years old, but 6 of them, right? So I'm going to bring this up. And I'm typing 6. Okay, and now let's find out how we're going to find the probability formula. Here is our formula, n factorial. You know what, I can, so not to go through this long calculation, what I can do, I can give you the link to calculator that's gonna calculate for you. Let me find it here. 1 second. This is L. Calculator for probability binomial distribution. Okay, we can use this one. Let me try this. There we go. We can use this one. So our n total probability of success was 0.39, right? Let me move it down. Yeah, 0.39, I see there. Probability of success. Okay. What else? Number of trials total, we have 6. And then what we have? Number of successes. Which one it is? Let's see. What do we have here? What's the probability that in the next 6, 18 to 29 years old survey, 4 will own tablet? 4, it's going to be our X because that's a successful amount. 4 of them have out of 6 have tablet, okay? So we are typing here 4. And that's it. Everything else will calculate itself. Click calculation. And let me see, zoom it. So what we need here, it's giving cases where it's equal 4 at precisely 4 people, less than 4, less equal 4, greater than 4, greater equal 4. So let's see which one is our case. Probability that specifically 4, right? Which means I'm going to my calculator. Specifically 4 is 0.129. Here it is 0.1, specifically 4, exactly 4, 0.129. Let's write down. It wants 4 decimals. Okay, we'll put it 0.129. And What was the fourth point? 1. Okay. 0.1291. Okay, let's check it. Good job. Now next one. What I'll do, the two of them, if there are more, you will continue, okay? Yourself. So what's the probability that in the next six, that's our n, right? All 6 will own tablet. All right, so all 6. So we have probability of success the same, 0.39 everywhere across the board. So total number of trials 6 and number of success also 6. Let's calculate, and we are getting 0.00352. 0035 then. 0.0035. Fantastic. I'll put the link under the video where the comments are, okay? I will pin it so you can see. So if you are looking on your cell phone, you have to click on the arrow, so extend, so you can see, otherwise it won't show. But on desktop, you will be able to see your laptop. What is next one? In the next 6, blah, 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 it says at least 4, which means we have to pick up greater or equal 4, right? So let's go here. Total is 6. Here is 4. So we're going to get calculation. At least 4, it's going to be greater, equal. Greater or equal. Here it is. 0.1657. So 0.1657. Checking. And what else? Will tablet in, so what's the mean and standard deviation? Okay, so this one we can do on Excel. What are the mean standard deviation of the numbers of the number of 18 through 99-year-old who will own tablet in survey of 6? Okay, the total is 6. We have 39, so we have it here. N is 6 to 39. What do we need to find? The mean. Okay, 2.34 to 4 decimal places. Well, we'll just add. Let me change the format. Click. Where is the format? Here. Format cell. I'll choose just a number. And 1, 2. Here I choose decimal. 3, 4. Okay. All right. There, I thought there will be numbers, but no. Okay, 2.3400. 2.3400. And the standard deviation 1.1947 for 1.1947. Okay, moving to next question. The last question, let me see. What assumption do you need to make? Remember, let me repeat one more time. What are the properties of binomial distribution? So we have fixed amount of total, just like n, this much, this much. Probability of success is the same from case to case. In our case, they mark down as a pi. I don't know why they put pi. That one, and then cases are independent, yes, and we have successful amount of cases. So let's see which one will match here. The probability of an observation being classified as the event of interest Pi is constant from observation to observation. That is one case. Because it's remember, probability of success. It's the same from case to case. Probability of observation being classified as the event of interest, and it's constant from observation to observation. Okay, that's a case. Next, the outcome of an observation is dependent of, no, outcome cannot be dependent. Outcome is independent. Okay. Next, each observation is classified into mutually exclusive. Yes, they are independent and mutually exclusive. Okay, this one and the last one, the outcome of any observation is independent of outcome of any other observation. So besides of B, everything else is satisfying, unless I misunderstood explanation. Well done. All right, moving to question number 6. What do we have here? So, manufacturing, let me move here so we can see. A manufacturing company regularly conducts quality control check at specified periods on the product periods on the products it manufactures. Okay, so they are providing control. Okay, historically the failure rate of LED light bulbs that the company manufactures is 15%. Suppose the random sample of 10 light bulbs is selected, so 15% is going to be our probability of success, 0.15. Let me type it here right away. It's going to be 0.15. Okay, and total amount, what was that? 10. Sample of 10. Total is going to be 10. Writing right here. All right. Well, let's see. What's the probability that none of the lit light bulb is defective? In that case, we are going to use again our calculator here. So we have total 10, probability 0.15, and none, x is equal 0. Okay, total we have 10. Here we have probability 0.15, and x is 0. None of them is defective. And its get calculation is none of them, 0.197. How many decimals? 4. 0.1969. Okay. 0.1969. Enter. Nice work. Next, what's the probability light bulb is defective? Exactly 1 is defective. Okay, same way, exactly 1. You put here 1, because total amount and everything else is the same. Exactly 1, 0.3474. 0.3474. Next, light bulb is defective. Probability 3 or fewer is defective. Okay, so 3 or less, right? Which means we are going to choose here 3, and we'll pick up less than 3 or less. Here we have only less, but we need 3 or less. 0.9500. Okay, 0.9500. You know how they do reality. So 3 or less. So you have to calculate probability of x is 0, probability x is 1, probability x is equal 2, probability x is equal 3, and then all 3 add them up, and that's what calculator is doing. All right, and next we have 4 or more. So we're gonna find out 4 or more, calculating 4 or more right here, 0.04. Okay, it's gonna be 50, 0.0450. 0.0450. Oh, what was that? 4 or more. Oh, 0.050. Okay, 0. Yeah, since we need 4. Okay. All right. Done. Moving question number 1. Now we are going to cover Poisson distribution. So what's the difference between Poisson distribution and binomial distribution? Poisson distribution, it's a type of distribution when during the certain time of the time interval, it's gonna happen gonna happen so many times. Okay, but when, we don't know. It's just within this interval that, let's say, we know that within 10 days it's gonna rain. That's a Poisson. Okay, so what do we need to know how we're gonna calculate? So the table of Poisson probability shows probability value x is equal x. Find the probability x is equal 1 for lambda. Okay, let me see. That's I opened example. Okay, let's do this to make it easy for you. Let me find calculator. Calculator for Poisson distribution. There we go. Okay. All right, so what do we need here? Poisson random variable in our case. Oops. X is equal 1. So probability that it's during the certain time of interval, it will happen only once. So is 1. And average rate 5.3. That was our lambda, right? Here. Okay. So let's see. And we need for Poisson random variable 1 x is equal 1, 0.02. How many decimals we need? 4 decimals. 0.0265. 0.0265. Okay, and so on. Then you already know if x is less than 1, greater than 1, less equal 1. So you have here less than 1, less equal 1, greater 1, and greater equal 1. So you can calculate and put the answers, okay? Let me open it. If there are all cases like that, it's going to change the numbers, but no, it didn't. Lambda changed, but that doesn't matter. Yeah, it will be looking for all cases for 1. Okay, that's question number 7. Moving to number 8. How many total we have? Questions. 15 questions. Okay. 7, 8. What do we have here? What are the properties that must be present in order to use the binomial distribution. We already know that, right? Oh, we have already, I opened the answer. Each observation is classified into one of the mutually exclusive and collectively exhausted categories. They are mutually exclusive. They cannot happen at the same time. Remember, they are independent. Next, the value of an observation is independent of the value of any other observation. We know that. Next, the sample consists of a fixed number of observations. It's also a very important part. And the last one, probability of an event of interest occurring, it's the same. Probability of success, we call, from one case to another. Okay? Following next, what is this one? For Poisson. Let's go over Poisson. So first is counting of number of times a particular event occurs in a given area of opportunity. So in a given area opportunity, it's a given interval of time. So it will happen so many times. The probability that two or more events occurs in an area of opportunity approaches to zero as the area of opportunity becomes smaller. The wider the time frame, the greater is a chance that will happen. So the smaller, then the probability will approach to zero. Next, the number of events that occurs in one area of opportunity is independent of the number. That definitely the cases are independent. And lastly, probability that an event occurs in a given area of opportunity is the same. So since they are independent, that probability is going to be the same from one case to another. Moving to number 10, what do we need to do? Oh, that's a z-score normal distribution. I guess I will record this in next video. Okay, so we stop on 14. Wait a minute. No, where did we stop? I think we stopped on 10, right? Yeah, number 10, from 10 to 15. Okay, I will record in next video.